What is this? Ah, this is our actual circuit of transistor switch. Using this circuit diagram in theory, same here. Current flows here. When you push the button, transistor conducts here. Our LED is in series with the voltage supply. I put an LED here as an output. So let's check the circuit if it's working or not. Power on the button. Oh! LED lighted. LED turns on. It seems that there is a reverse voltage happening here, or leakage current, making the LED lighted. Turns on here. So I think we need a pull down resistor. Why? Because of this push button, the input of the transistor is hanging, and we use that push button in logic circuits or in digital electronics. The transistor didn't know what its input. Is it 0 or 1? It's hanging, so there's a reverse voltage happening here, or leakage current, or a transistor is floating because of the switch. We need an input here. It must be a closed or 1 or grounded 0. But the circuit is hanging. That's why the LED lighted. A reverse voltage is happening. Also, there is a leakage current here. So I decided to put a pull down resistor here. Trial and error. And this LED turns up. So if we use this kind of circuit, this is the actual circuit. When you push the button, LED turns on, but still turns on a little. That voltage is the reverse voltage. Still the LED conducts or lighted. Even the push button is open. Reverse voltage is happening. The transistor didn't know what its input because of this push button is hanging, floating. You need to short the circuit here or ground the circuit here. We need a resistor here. I calculated the value for the resistor already. Well, so we'll try to build we try to put a resistor in the base to the ground, but the value of the resistor is I don't know how to calculate. I'm assuming that the voltage here is equal to the voltage here, or equal to the voltage here, or equal to the voltage here, equal also. So the current here, IC, is equal to the IE. Since we're going to saturate the transistor, seems that the current here, IE, is equal to the current here when you push the button. This current here is the series current here. What's wrong with the magician Ohm's law? Should be current entering here, leaving here, leaving here. Should be different current here, IB, and current RS, but I'm assuming that the current here is the same as here, also here. But I use the current here, 0.025 ampere, and I calculated the value of R using Kirchhoff's voltage loop again. for the voltage here, and Ohm's law magician again, voltage over the current, since current is 0.25 milliampere. What's wrong with this? And I'm going to connect a resistor here because this circuit is defective. It leaves the circuit hanging. See, then LED should not be lighted, because the operation of the transistor is when you trigger the base current here and current flows here, the transistor conducts. What's wrong? There's a phenomenon here, reverse voltage is happening, so I decided to put a resistor here. So let's build the circuit again, or let's troubleshoot this circuit. Let's modify the circuit with the with the pull down resistor here, so that the transistor know what's its input should be 0, not like this, leaving the transistor in floating state if you don't have a grounded resistor here, or just short circuiting the wire here, the terminals. But since we're using push button, leaving the transistor in hanging state. So let's troubleshoot, modify the circuit. Okay, let's put I calculated the resistor value here. It's 478 with with voltage of 11.95, Kirchhoff's voltage loop and Ohm's law, using the current here, this one. Okay, let's modify the circuit. Thank you.